Hello, my name is Messiah Jones, and this is my optimization project. It's called Optimizing with Messiah. All right, start this off. You can see my object. It's a rectangular prism with a square base right here. Here's it in real life because the picture is kind of dark. It's a rectangular prism with a square base. The measurements are the base length. The base length of the square is 7/8 of an inch. So that's 0.875 inches. The height is 3 inches. So now into the formulas. The variables I'm looking for are the volume and the surface area. The formula for volume equals base length squared, because the base length is a square. Base length squared times height to cover the whole volume. For surface area equals 2 base length squared, because there are 2 bases, plus 4 times base length times height, because there are 4 sides. To get the values of these of the actual object, the volume is 0.875 squared times 3 to get a volume of 2.30 cubic inches. The surface area is 2 times 0.875 squared plus 4 times 0.875 times 3 to get a surface area of 12.03 square inches. Now what I'm going to be doing with these numbers is I'm minimizing the surface area while keeping the volume constant. The formula I'm minimizing is the surface area formula, 2 times base length squared plus 4 times base length times height. My constraint equation is the volume formula. Volume equals base length squared times height, with the volume is 2.3 cubic inches. To get into it, first I want to express the surface area equation. I want to express it in one variable because, as you can see, I have base and height. I want to express it I chose in terms of base length, so in terms of B. To do that, I take the volume formula and I transform it into, I put H on one side basically. So 2.3 cubic inches equals base length squared times height. I divided 2.3 by the base length squared to get H equals 2.3 cubic inches over base length squared. And I'll plug that into the surface area equation. So I'll replace the H with what it equals. So surface area is 2 base length squared plus 4 times base length times 2.3 cubic inches over base length squared. And to simplify it, is surface area equals 2 times base length squared plus 9.2 over base length. Now we're looking for the critical points. To do that, first we have to differentiate the equation I just came up with. So I differentiated it. I used the power rule, to get 4 base length minus 9.2 over base length squared. I made it equal 0 so I can find the critical points. Now what I have to do is I'm trying to get the base length by itself. So first I added 9.2 over base length squared. I added it to both sides. So now 4b equals 9.2 over b squared. Then the next thing I did was multiply both sides by b squared. So now it's 4b to the third equals 9.2. The next thing I did was divide both sides by 4. So it's b to the third equals 2.3. The next thing I did to get b, the value of b, is I found the cubic root. So b equals the cubic root of 2.3, and that equals 1.32. So 1.32 is the only critical point. To double check, I used number line analysis. So basically what I did was I found intervals, and my intervals were any number lower than 1.32 to 1.32. And my second interval was 1.32 to any number higher than 1.32. With the first interval, I just chose the closest whole number. So I chose 1. So the equation, surface area prime to in terms of 1, 4 times 1 minus 9.2 over 1 squared equals negative 5.2. So I took note that it's a negative. My second interval, 1.32 to any number greater than 1.32. I just chose 2 because it's easier. So surface area prime in terms of 2, 4 times 2 minus 9.2 over 2 squared. I got positive 5.7, so I took note that it was positive. So as you can see, it went from negative to positive, which means it was increasing. And that was the only critical number I had. So it proves that it was the minimum because it only increases from there. It doesn't go any lower. Yeah. So here I have my graph on the back. All right, the optimization result. The lowest dimensions, well, basically the lowest surface area possible while keeping the volume constant is a cube with a base length of 1.32 inches. So all sides, and a height of 1.32 inches. So all sides equal 1.32 inches. That's basically what it's gonna look like to have the lowest possible surface area while keeping the same volume. Here I have a graph to show that. On the y-axis, we got surface area in inches, base length in inches. This vertical lines, they are, the red one is the original base length, and the blue one is the minimized base length. So the original base length was 0.875. The optimized one is 1.32. And then these dotted lines, they are, the red one is the original surface area, blue one is the minimized surface area. So the original had a surface area of 12.03. The minimized one had a surface area of 10.45. Yep, 10.45. The black line is not perfect. It's supposed to be like a curve kind of. But it is the surface area with constant volume. So as you can see, with the original, it's higher than the minimized one. The minimized one, it goes down and it comes back up, and back up, and down. And that's it.